Hello YouTube denizens, this is Prashant. Welcome to my chemistry channel where I document my work on chemistry. In this video, we're going to be looking at a very straightforward JEE main style question where we're going to be looking at a straightforward titration involving KMnO4. Well, in this titration though, we don't need to do any guesswork. They have already given us the equation. Let's directly dive into the question. This is of course from the topic redox reactions. Alright, so the question basically goes like this. A 0.1 molar KMnO4 solution is used for the following titration. What volume of the solution will be required to react with 0.158 grams of Na2S2O3? Now, this Na2S2O3 is actually going to be called sodium thiosulphate. Now, first of all, we need to find the number of moles of this, which means we need to calculate the molecular mass of this. So let's get that out of the way over here. So Na is going to be having atomic mass is 23. Sulfur atomic mass is going to be 32. Oxygen is going to be 60. Now, when you do end up adding up properly for the Na2S2O3, you will find out that it is going to work out as 158 grams per mole, meaning the molecular mass for this works out as 158. I'll just show you the calculation. You can try it out for yourself later. So it's 23 into 2 plus 32 into 2, Na2S2 and then O3. So it is 16 into 3. Add them up, you'll be getting your 158 over here. Alright, so let's now break the question down over here. They're asking a 0.1 molar KMnO4 solution is used for the following titration. So the next piece of work which we'll have to do over here involves understanding the equation a little bit more. So let's put the equation down. So S2O32 minus plus MnO4 minus. Now, I am not going to be adding the water pieces over here. I am only looking at what is undergoing oxidation, what is undergoing reduction. Why will I be doing that? Very simply because all I am interested in doing is calculating the N factor for each of the species over here. So what is N factor? N factor is going to be nothing but the number of moles of electrons involved in that particular reaction which is happening for 1 mole of whatever compound over there. The electrons can be either absorbed or it can be given out as well. It doesn't make a difference. So the basic principle is number of electrons transferred per 1 mole of the substance is called as N factor. Okay. So in this reaction here, the products obtained are going to be SO4 2 minus and MnO2. So now let us identify the oxidation states for each of these over here. Sulfur in S2O3 2 minus is present in +2 oxidation state over here. I'm of course assuming you guys are able to calculate the oxidation state for yourself. I will discuss a little bit more on oxidation state in some other video, how to calculate it. Now let's look at the oxidation state for the manganese over here. Manganese is in +7 in the reactants. It goes to +4 in the products over here. And in SO4 2 minus, sulfur is present in +6 oxidation state over there. So now let's put down the N factor for each of these over here. So S2O3 2 minus is becoming SO4 2 minus, right? So +2 length, you're going to be having the sulfur going to +6 over here. So per sulfur, each sulfur atom is losing 4 electrons over here. All right. But there are 2 sulfur atoms in the S2O3 2 minus. So you're going to be having N factor being per sulfur it is 4 electron transferred. For 2 sulfurs it's going to be 8. So N factor for this is going to be 8 in this particular reaction here. Next up, the MnO4 minus is going to become MnO2 in this particular reaction here. As you can see here, it is in a tiny bit of a basic medium, which is why it is going to be going into MnO2 here. If it is a strongly basic medium, it will be going into MnO4 minus 2. And since they have not mentioned it, we can guess over here that it is a mildly basic medium to neutral medium, which is why it is going to become MnO2 in this particular case here. Okay. The change in electrons is going to be +7 to +4, meaning the MnO4 minus, the permanganate, should have absorbed 3 electrons in this process over here. So the N factor for this guy, let me change back from the black color here. N factor for this guy works out as 3 in this particular case here. Alright, now the entire process becomes very straightforward and simple for us. What is going to be the process now? We've got the N factors down. So simply put, this is a nice clean redox reaction. When it is a nice clean redox reaction, we can say equivalents of each of the substance is going to be equal, because for all of them, if it is a proper balanced equation, or if they are going to be reacting properly, the electrons have to be balanced away. Why should the electrons be balanced away? Very simply put, electrons and protons are highly unstable species, so they can never exist by themselves in any medium, in any condition, in a free manner. The moment an electron is produced, it will end up getting consumed by something else. The same way, the moment a proton is produced, it has to be consumed by something else. Otherwise, the proton will never be produced by the acid. That is why HCl in gas form is not an acid. Pure HCl is not an acid, it is a covalent compound. But HCl, when it is in water, when that HCl gas is dissolved in water, it is going to be an acid. Why? Because the moment the HCl is in water, it can throw the H plus out, which is now accepted by the water molecule to become H3O plus ion, which is called as the hydronium ion. So when it is present as H3O plus, it is not a free H plus, it is in combined form only. Okay, so the basic principle is the number of electrons involved have to be cancelled out. Whatever is giving electrons out, something else has to accept all the electrons immediately. That is the principle to be used over here. Meaning equivalence of S2O3 2-, which is going to be giving the electrons out, should be equal to the equivalence of MnO4-, which is going to be accepting those electrons. Effectively, the one which is accepting the electrons is going to be acting as oxidizing agent. The one which is going to be losing the electrons is generally called as the reducing agent in a reaction. Okay. Now, we've got the N factors out. Now, let's play with this and see what is going to be happening over here. So, the N factor for the S2O3 2-, we got it as 8. And the N factor for the MnO4-, we got it as 3. So, all we have to do is put down the equivalence over here. So, the idea was equivalence of S2O3 2- should be equal to equivalence of MnO4-. Equivalence is going to be nothing but moles into the N factor. We've got the N factor part down over here already. So moles can be directly calculated as volume into molarity. So we'll be having, in this particular case here, let's assume VML of KMnO4 is used over here. Alright. So VML into the molarity. The molarity has been given as 0.1 molar over here. Correct? So into 0.1 molar into the N factor for the KMnO4, which is 3. This is going to be nothing but equivalence of MnO4-, should be equal to moles of the S2O3 2- into its N factor. They have given us it is 0.158 grams. Molecular mass of this guy we had seen in the previous part over there as 158 grams per mole, meaning this is 158. So effectively we can say it is 0.158 divided by 158. But there is one small thing over here, that is that we are going to be having volume in ml taken over here. We have to pay attention to that. That means this calculation is not really going to be giving me moles. This gives me millimoles, not moles. So if I want to actually put it as 0.158 by 158 over there, I should be using volume in liters over here, or I can multiply this side by 1000. Moles into millimoles, we can do the conversion straight away. So you got moles converted into millimoles over here, multiplied by the N factor for the S2O3 2-, which we had calculated in the previous part as 8. So this 8 comes out over here. So let me now re-put this down into just the equation form to solve it off straight away over here. We'll be having volume V into 0.1 into 3 being equal to, in this particular case, 0.158 divided by 158 into 1000 into 8. 0.158 by 158 is 1 by 1000 effectively, right? 158 into 10 power minus 3. So these three will all cancel out beautifully over here. So we will be left out with V is equal to 8 divided by 3 divided by 0.1, which means it is 8 into 10 by 3. So it works out as 80 by 3. 80 by 3 should be what over here? Of course, it is going to be 26.67 ml. So we are going to be having the volume of KMnO4 needed over here, 0.1 molar KMnO4 solution needed over here, works out as 26.67 ml. This question is a typical JEE mains question, and I would not say it is going to be an easy or a difficult question. I would say it's a moderately difficult JEE mains question if this type of a question shows up in a JEE main style examination. I'll of course catch you guys in a different video. Take care till then, guys. I hope this video benefited you guys. If it did benefit you, please do share and subscribe with your friends who are also probably going to be benefiting if they will benefit from it. Thank you very much. Bye bye.